All right, so we're going to be focusing on question 31 from math practice test number 1 out of the red book. So right now, get out your red book, hit pause, and find question 31 so we can get ready to do that problem. All right, so question 31. We're getting into some geometry. All right, we're getting into proportionality, similarity, ratios with figures. These are all words that should be triggering some things for you. So we're going to look at this, and the question is, what is the length in centimeters of a certain segment in a figure? And we find out earlier that the figure is rectangle ABCD. So I'm going to draw, first and foremost, right, draw a picture. We're going to draw a rectangle ABCD. All right, triangle ABCD. We know that the perimeter of triangle ABCD is 96 total centimeters. All right? So if we're using our word problem strategy, we would have already written out, we're trying to find the length of AB. All right? And secondly, what do we know? We know that the perimeter equals 96 centimeters. So the total perimeter. Now you got to understand what perimeter means. Perimeter means the distance around a figure. So as we're looking at this, all right, this is all the information we have except one other thing. They tell us that the side lengths AB to BC follow this ratio. So side length AB to side length BC, the length of those sides follows the ratio 3 to 5. Now what this means, right, and you got to understand what the essence of that statement means. This is what unlocks the problem for you. All right? What it says is that no matter what this side length is, all right, this is going to be 5 times that, or if this is 3, that's the spot where I messed it up. So this is the thing, this ratio right here is what unlocks this problem, okay? And so whenever you have a ratio given for certain side lengths of any figure, what you know is that no matter how big the rectangle is or how small the rectangle is, these side lengths will still follow the same ratio. It's called, they're proportional, okay? So a rectangle that was this size, all right, could be proportional to this. In geometry, we call that they are similar figures because they follow the same ratio in their side lengths. So because of that, what we want to do is we want to get this in an algebraic form so we can start solving it. And so what we're going to do is we're going to take the 3 for AB, all right? And anytime we want to turn it algebraically, we're going to represent that it could be for any size rectangle by showing 3x, 3 times some number, right, variable. And then BC would be represented with 5, but we have the same situation here. 5 times x and 3 times x, this is how we would set up this ratio in this rectangle. And from here, we actually start to solve. Because what we know is that we can now find the perimeter in terms of x. So perimeter, okay, is going to be 3x plus 5x plus 3x, right? This is a rectangle, plus 5x. But we also know that perimeter is 96. So we've got a nice, simple, approachable algebraic expression, algebraic equation to solve now. So we need to solve for x. Once we solve for x, don't forget, we're going to plug it in here because we're finding the length of AB. So x is in our final answer, but let's get x first. So 96 equals 3 plus 5 plus 3 plus 5 is 16. Divide both sides by 16. Again, simple algebra here. X equals 6. All right? Now, we're not finished. We take this, plug it in up here for the length of AB. So AB equals 3 times x, which we've already said. We're just using what we already know, which is the same as 3 times, we know what x is, which is 18. And the answer is B.